Hello, this video will introduce students to the protocol that organic chemists use to qualitatively evaluate the relative acidity of a series of organic acids. Let's start by defining an acid and a base. According to the Bronsted-Lowry definition, an acid is a molecule that can donate a proton, while a base is a molecule that accepts a proton. For example, consider the reaction when an acid HA reacts with a base B with a lone pair. The base uses its lone pair of electrons to abstract the proton from the acid HA to form the conjugate acid HB+. The bonded pair of electrons between H and A are simultaneously transferred to A, resulting in the conjugate base A-. If the conjugate base is not stable by itself, that is, if it cannot stabilize the negative charge or lone pair depending on the case, it will grab the proton back from the conjugate acid to regenerate HA and B, which is the reverse of the above reaction. Hence, the strength of an acid is determined by the stability of its conjugate base. In a case when we are comparing acid strengths of two acids, the stronger acid must donate protons more readily than the other one. For example, when comparing the relative acidities of two acids HA and HC, the stronger acid is the one that donates protons more readily to the base B. This is determined by the relative stability of their conjugate bases. In this particular case, the base B abstracts protons from HA and HC to generate the conjugate bases A- and C- respectively. In this scenario, if the conjugate base A- is relatively more stable than C-, then the corresponding acid HA will be relatively stronger than the acid HC. The relative stabilities of conjugate bases can be rationalized based on the atom or element effects, resonance effects, hybridization or orbital effects, and inductive effects. When attempting a problem on comparing acid strengths, example between HA, HB, and HC, follow this protocol. First, draw the conjugate base corresponding to each acid. In this case, the conjugate bases for the acids HA, HB, and HC are A-, B-, and C- respectively. Second, evaluate the stability of these conjugate bases using the atom, resonance, orbital, and inductive effects, and rank them according to their stability, rank 1 being the most stable. Let's say the order is rank 1 is B-, which is stronger than C-, and C- is stronger than A-. The acid corresponding to the most stable base would be most acidic. So in this particular case, the order of acid strength will be rank 1 is HB, which is the most acidic, rank 2 is HC, and rank 3 is HA, which is the least acidic.